This video is an answer key for worksheet 28, solving 1 and 2 step inequalities. There should be nothing to check on the front side because the I do was already done and the we do was done together through an Edpuzzle video. So it's just looking at the second page. For the first one, what is being done to the variable is it is being multiplied by x. X is being multiplied by 6. I know that because they're touching. 6 is the coefficient. To undo that, you would need to divide by 6. Because it's multiplying and dividing by positives, not by negatives, there is no need to flip. Now I will show my undo work, dividing by 6 on both sides of the inequality. This isolates the variable on the left, and 12 divided by 6 is 2. My solution is x's that are less than 2. That would have an open circle on the number line because the 2 is not equal, it's not included, and values that are less go to the left. The scale of your number line does not matter. For example, I'm doing a scale of 1. It also doesn't matter if 2 is placed in the center. What matters is that there's an open circle at 2 with an arrow to the left. And then I can pick any value less than 2 to substitute and check my answer with. I'm just going to pick the next closest whole number, which is 1. 6 times 1 is 6. Now the left is simplified. And my statement is 6 is less than 12. That's true. Because I got a true statement, I know that using an x less than 2 is correct, so my answer is correct. For the second problem, there are 2 steps being done. X is being multiplied by -3. Also, 2 is being added. To undo these, I would divide by -3 and subtract 2. These would be done in reverse order of operations. Because it's multiplying or dividing by a negative, yes, the inequality symbol is going to have to flip in order to prevent a false statement. And I'm going to set mine up ahead of time because I don't want to forget about that. I'll show -2 on the left, -2 on the right. My equivalent problem is -3x is less than or equal to 15. Now I'll divide by -3. This isolates the variable. 15 divided by -3 is -5. X's that are greater than or equal to -5. I'll have a closed circle because of the equal to part of that symbol. It means that -5 is included and values are greater as you go to the right. Again, it does not matter where the -5 is on your number line, or if you have a different scale. What's important is that you have a closed circle at that value and an arrow to the right. I'll pick the next closest integer, which is just a -4. You can pick any value on that shaded region of the number line. And now I'll simplify the left-hand side. -3 times -4 is 12 because they have the same signs. 12 plus 2 is 14, and my statement is 14 is less than or equal to 17, and that is true. The third one is also 2 steps. X is being divided by 2, but also adding 4. The inverse of these operations would be multiplying by 2 and subtracting 4. I don't see multiplying or dividing by any negatives. These are positives, so nope, there is no reason to flip. For the algebra work, I'll show reverse order of operations. First subtracting 4. My equivalent problem is x divided by 2 is greater than 3, because 7 minus 4 is 3. Now I'll show multiplying by 2. X is greater than 6. I'll have an open circle and an arrow to the right to represent the greater than sign. the placement of 6 and the scale does not matter. I'm going to pick a value that is greater than 6 to check with, but because I see that I'm going to have to divide it by 2, I would personally prefer to choose a value that's easily divisible by 2. 8 divided by 2 is 4, and 4 plus 4 is 8. 8 is greater than 7 is a true statement. What's being done on the fourth one is x is being multiplied by 4 and subtracted by 3. The inverses would be divide by 4 and add 3. There are no multiplying and dividing by negatives, so there's nothing to flip. I'll just solve these two operations using reverse order of operations. This leaves me with 4x is less than 12, and then I'll divide each side by 4. To get x's that are less than 3. Then we'll have an open circle and go to the left for less than. I'm going to pick 2 to substitute with. 4 times 2 is 8, and 8 minus 3 would be 5. My statement is 5 is less than 9, and that is a true statement. For the fifth one, what's being done is x is being divided by negative 4. The inverse of that would be multiplying by negative 4. Because I see multiplying or dividing by negatives, this is a problem where I will need to flip or invert my symbol. Otherwise, I would get a wrong answer. And I like to set that up ahead of time so I don't forget about it. Three times negative 4 is negative 12. And because I have x's that are less than or equal to, I'll have a closed-in circle for the equal to part. And then values get less as you go to the left, more negative. And I will select something more negative than negative 12, but also something easily divisible by 4. I'll pick negative 16. Negative 16 divided by negative 4 would be positive 4 because they're the same sign. 4 is greater than or equal to 3 is a true statement. What's being done on the last one is p is being subtracted by 5. The inverse of subtraction is addition. There's no flipping here because it's not even multiplying or dividing, let alone multiplying or dividing by a negative. I'll show my algebra work on both sides of the inequality, leaving p is greater than 9. Because the greater than symbol does not include the number, I'll have an open circle at 9, and I'll show you values going greater on the number line to the right. And then I will simply pick 10 to do my checking with. 10 minus 5 is 5, and my statement is 5 is greater than 4. That is a true statement. Like on your equation assignments, you'll get credit for the do-undo plan, the algebra solving work that you see me showing in orange, the solution on the graph, and the checking. The checking can be different. We don't all have to pick the same values to check with. So if you're looking like, oh no, Miss Halpern, I didn't pick a 1, I picked a 0, that's okay. You pick something that's less than 2. So this is a little open to interpretation. It doesn't have to be these specific values, even though some of you are a lot like me and you just pick the next closest whole number, the next closest integer, because that just makes life easier. But some of you like to pick, for example, you would pick maybe 6.01 just because it is barely greater than 6, and that's okay. So your checking doesn't need to be these specific numbers, but the number that you check with does need to fit the parameters or the boundaries of your answer. So that would be fine. Since there are 1, 2, 3, 4, 5 checks times 6 questions, they would end up being 3 points per check. So if you see a score, that's where the score came from.